All right, well, welcome here, Brian. We're happy to have you in lovely Rosedale today. Sun's shining here, and I'm sure it is in Vancouver Island as well, but we're glad to have you here today. We've had quite a long relationship, actually, when we first became acquainted with each other. And over the years, we've followed you to a few different operations, and you always seem to drag us along for the ride. So
you keep hunting me down, yeah.
So we want to just get a little bit about your background, and hear a little bit about what kind of brings us together on a lot of common projects. And so maybe start by just telling our listeners a little bit about your background in reliability and how lubrication has played into your daily responsibilities.
Okay, first of all, Rick, thanks for inviting me. Been involved in reliability since I was 16, to be honest. Was in the marine industry for 25 years, operations and maintenance of ships. Then came to Canada in 1999, worked in a number of industries, food, power industries, oil and gas, pulp and paper. I've been around a bit. So something in common with all those industries, they have rotating equipment. And where you have rotating equipment, you have lubrication. And where you have lubrication, you'll have lubrication issues. So that's kind of a bit about my background. That's the last 40 years in a nutshell. So, yeah, it's been a long time.
So you working with a wide range of industries, what are some common misconceptions that you've heard at these various places around oil filtration and lubrication cleanliness?
Pretty much everywhere I work, it's from a lubrication filtration perspective, it's too expensive. And my answer to that is the alternative is too expensive. The common issues, contamination, water ingress, wear metals, and not understanding the consequences of not dealing with that. So what I like to say is you've got two types of failure. The catastrophic failure, which gets everybody's attention, and what I class as an insidious failure. It's something that oil cleanliness affects. So people may be happy with getting 7 to 8 years out of their equipment, a reducer, when really they should be looking for 20 to 30 years life expectancy. And that's the biggest thing I see is people not understanding that oil cleanliness plays a major part in life extension and the reliability of the equipment.
So it's like a failure of negligence, essentially, something that's not being paid attention to, and so it doesn't fail all of a sudden all at once, but over time.
The argument I get is usually, well, we change the oil once a year, that's good enough. In actual fact, it isn't. It's really not that effective. Just saying you change the oil once a year, it's first of all, there might be nothing wrong with the oil. So you're changing it for no good reason if you don't do oil analysis. And secondly, it's not that effective because changing the oil doesn't remove all the contaminants. You'll be lucky if it removes 10, 15% of it. And depending on the type of system, the hydraulic lube system, or even a reducer or a pump. So that's why it's ignorance, for want of a better word. It's right. They don't really know.
Well, that brings up a great point. I recall one project we worked on. It was a big mining wheel loader, and we were demonstrating the CC Jensen filter on site. So we ran the final drive oil through the filter for a period of time, took samples before, after, compared, showed a massive 90% reduction in contamination, and said, yeah, this oil is cleaner than it's ever been. And their shop foreman said, okay, well, that's really interesting. Well, it's time to change it. We've reached our 2,000 hours, whatever it was, dropped the oil, replaced it with new, and it was dirtier than what we had just drained out.
It brings up an example I've just thought of with the mine site, oil sand site I worked at with very large reducers. You might remember the reducers I'm talking about.
I may.
These had anywhere from 800 to 1,000 litres of synthetic oil in these reducers. And when I it was a new startup plant, and after about a month or two, they decided to change the oil, which was totally impractical. 16 reducers with about 1,000 litres of oil in it was not feasible. So long story short, there was a lot of discussion, a lot of argument about to change the oil nuts. So we actually ended up purchasing the CJC filter units, installing them. You probably remember that because there was quite a lot of them. And we installed them, and again, long story short, after 12 years, that oil is still in the system. It's monitored, it's clean, so those units more than paid for themselves. So
would you say that installing those filters was even easier than doing an oil change?
Well, it would have been impossible. You've got 1,000 litres oil, you've got one lube truck which holds one oil change, and you're trying to change 16 units of oil in a 3-day shutdown. It physically wasn't possible to do that.
It's time-wise not even feasible.
Well, when it's minus 25 outside as well, the oil doesn't pump that fast. You've got to drain it. You've got to replenish it, and it was just physically impossible to do it in a 3-day time span. We didn't have the amount of oil. We didn't have the amount of equipment. We didn't have the people. So my argument was, why would change this oil in the first place?
Yeah, well, that's a great point. I feel like we're saying point a lot, but what's interesting about that is the way you describe this operation of changing the oil in all these 16 gearboxes would have required those gearboxes to be down for the shutdown. So you had a limited time with which to do that, whereas by installing a kidney loop filter, that could be done while the gearbox was operating. Did that end up happening?
Yep, it was all done while the plant was running. Obviously, you've got the valves installed, the suction valve, the discharge valve. It's just a matter of case of running power to the filter unit and hooking it up and starting it up. It involves zero downtime. But I might add the cost of the filter unit. Obviously, they're not cheap. Well,
it's an investment. You never get anything for nothing.
No.
So there has to be some kind of input.
High quality unit, they're built to last. They're built for the environment. Those particular units had heaters on them for the cold environment. But what I was trying to say is the cost of the unit was replaced by just one oil change. This is 1,000 litres of synthetic oil at $12 a litre, plus the cost of the labour to drain it. It would have been probably a 5 or 6 hour exercise in doing that, minimum. So you factor all these things in. It's one oil change paid for the filter unit. So thinking you're changing the oil every year and doing the right thing is actually you're doing more harm than good.
Right. And like you said, even when you're doing an oil change, you're not getting all the contaminants.
No, you're not.
Out of the system.
Not for a heavy gear oil. It's a 220 or a 320. As soon as you turn that reducer off, all the contaminants just fall to the bottom of the reducer. You're lucky if you get 5-10% of the contaminants out. Yeah. So a lot of ignorance around filtration and oil changes and oil analysis, which I see in pretty much every industry I've worked in.
Yeah. In your experience, what role does oil cleanliness play in asset reliability, and why do you think it still gets overlooked?
It gets overlooked because most people don't measure it. A lot of companies I work with, or I've worked in, don't really have a robust oil analysis program. Looking at ISO cleanliness, not just ISO cleanliness, additives, wear metals, all those other good things which kind of sum up what oil analysis is all about. But like I say, if you're not measuring it and setting targets, you really don't know what's happening.
You don't know what you don't know.
Exactly. You go to your doctor and you do a blood test and it comes back and everything's good. You're good for another 2 or 3 years, depending on your age. If you're a bit younger, it might be every 5 years, but in my case, it's every 2 years. So that's the type of thing. If if you don't know what you don't know, then you can't react to it. So once you have the data, then you set cleanliness targets, then you try to achieve them. It's not always possible to achieve those targets, but that's what you should be trying to achieve, is the cleaner the oil, the drier the oil, the longer your equipment will last. So do you want it to last 20, 30 years, or do you want it to last 7 or 8 years? And that particular example we talked about with this oil sands, this mine site had a life expectancy of 40 years. And you're talking about large reducers. If they'd allowed it to run with dirty oil, you're probably lucky if you get 20, 25 years out of those reducers. And after 20, 25 years, you've got upwards of 48 reducers in total, all on the same failure mode path. And when you don't have 48 reducers in the warehouse to replace them with. So the intent and the philosophy I tried to instill with the plant was, if you really want these assets to last 40 years, then you really need to make sure the lubricant is clean and dry for the lifespan of the equipment.
And now you're talking about equipment that was installed from new. Yeah. Because this was the first oil change that you were talking about.
Yeah, the concept is you get a running period with a reducer, and it's common practice that after it's the same as your engine oil, or used to be, not so much now, but it's the running period is a month, 3 months. After that time, dump the oil, put a fresh charge of oil in. Well, that philosophy is 15, 20 years out of date, but it's still prevalent now. People are still doing that without understanding it. There's nothing wrong with the oil that's in the unit, apart from it might have some contaminants, some wear metals, which are easily filtered out. The other thing is you, like you say, you don't get all the contaminants out. So what's the best thing to do? Put a filter unit on it. Put a filter unit on the asset. Check the condition of the oil. Is it good? Yes. Carry on.
Yeah, it raises an interesting notion that, being as we handle oil cleaning equipment, and a lot of these problems happen over time, and the contamination builds up, and then it gets to a critical point where now they're faced with either doing something or facing the consequences, and so we end up trying to extend the life of dying equipment in a lot of cases already. And a lot of people don't recognize the benefit of putting something on to protect new equipment, so they don't end up in that place in the future. Is that something that you've also experienced?
Yeah, it's another factor that having clean oil or as opposed to dirty oil is it extends the life of the lubricant, right? So wear metals, water, high heat all lead to oxidation. So if you've got large volume systems, not just reducers, hydraulics, lube systems, and you're not keeping the oil clean, that oil won't last as long. You'll get to the condition where it's oxidized, for want of a better word, starts creating varnish, viscosity issues, and accelerated failure. So it's I liken it to kidney failure. If your kidneys fail, then what are you going to do? You need a kidney dialysis machine to clean up, or you suffer the consequences. So, yeah, there's lots of misconceptions about filtration and what it does and the benefits of it. So, and kind of highlights the idea that it's too expensive. The alternative is probably 20 to 30 times more expensive.
So you see a lot of sites that, I guess the ones that don't know what they don't know, but also the ones that do know what they don't know. What are some of the signs of a site that you look at, whether they're doing a good job of lubrication, handling their lubricants, or the alternative that?
That's a good question. The first thing I do when I go on site is, can I have a look at your lube room, right? And that I don't need to look at the plant. I say, look in the lube room or where you store and handle your lubricants, and that tells me probably more than I need to know about what they're actually doing in the plant. they're not storing and handling lubricants and pre-filtering or preconditioning the lubricant before they're using it, well, they're probably not doing anything out in the plant there for contamination control or offline filtration or anything like that. So that's a starting point.
So it's sort of like looking at a house from the street, and the place that has, lawn that's this high and window shutters that are falling off, you have an idea of what it's like inside the house as well. So the lube room is sort of the
first impressions are everything.
First impression.
And the first impression is, for me, it's always the lube room. Generally, you don't have to ask any questions once you look at the lube room. You look at the condition of the equipment or the age of the oil or the way they store and handle the grease. It all told a story.
Or maybe even a better comparison is if you look at somebody that just has money strewn all over their house, as opposed to someone who has a safe or a vault, of how they treat the valuable objects to begin with, probably gives you an idea of how they're spending that or using it in other ways.
It's a good analogy, because essentially the equipment you've got on the plant are valuable objects. There isn't much you can buy for less than $20,000 when you look at pumps or reducers. It's and the way people treat them. And would you treat your vehicle any differently? I mean, you see people. I've known people who haven't done oil changes on vehicles. Man, he was in reliability as well, so I shouldn't really mention his name. But it's the analogy I like to look at is somebody who owns something as opposed to somebody who rents something. If you own it, you take ownership of it, you look after it the best you can. So generally somebody who rents something goes, I'm only here for 3 months, 6 months, don't really care about the place. It's probably a bad thing to say about people who rent somewhere, but they take less care of things. And it's the same with a plant. People who work in plants, you're going, you own this plant. It's your responsibility and you do your best to look after it. Don't think it's somebody else's problem if you see something wrong with it. And that's kind of the attitude I see in a lot of plants. It's that they don't take ownership of it. Sad but true.
One of the things that we do deal with from time to time is the belief that the type of system will dictate the type of care and attention you need to play to it. And what I'm thinking here is for maybe a hydraulic system with servo valves, something with very fine tolerances, things like that, and that will get a lot of attention for. That will get a lot of attention for taking care of the oil, but something like a reducer where there's big teeth. I mean, some of those ones you described probably have teeth that are several inches wide, and the mindset is that, oh, there's so much material in there that's contacting. It's big, robust. The thing could chew up gravel if it wanted to, so I don't need to pay that close attention to it. How do you deal with that misconception of the criticality or the value of certain equipment?
I get to the analogy of how long do you want things to last, right? I mean, yeah, you've got big clearances and a reducer, and the tolerances aren't as critical, but the cleanliness, the dryness, the condition of the lubricant, not just that, the additive part, the viscosity. That all plays a part in the longevity of that equipment. And if you've got a warehouse full of spare reducers and you don't take care of them, but it's not just replacing it; it's the whole life cycle cost, right? So yeah, I mean, some of these reducers anywhere from $100,000 to millions of dollars, and it's not just the cost of the asset. What you've got to factor in is the impact of changing that asset out at a given time, whether it's 20 or 25 years or however long it lasts. And there's no guarantee that the unit you've taken out of the warehouse will be in a condition that it will last. There's a thing called infant mortality. Now, I've seen this quite often is things aren't stored or handled correctly in warehouses, and they install them as a spare unit, and within a year or two, they failed again. I've seen that a number of times because warehousing or storage and handling of equipment in a warehouse isn't what it should be. And sad but true, but there you go. So from my perspective, if you've got a stable system, a reducer that's looked after, has got clean, dry oil, and you monitor the condition of the asset, it should last the life of the plant.
I know a common practice on new equipment like that is to do a run-in at the factory. Then they drain the oil out before shipping because they can't risk shipping a volume of oil in a piece of equipment in case of leaks, whatever. So I imagine often it would arrive at a warehouse with no oil in it, and what's there in its place is air, and what's in the air is moisture.
So usually they give occasionally, usually they'll put a pack of desiccant in it, but that's got a lifespan as well. It can only absorb so much water.
So you're doing maintenance on the unused equipment even.
Occasionally they'll charge it up with nitrogen and kind of give it a purge to keep the water out. But then you get things like false spindling, vibration, that type of thing. It's and people think, people have this belief that something that's in a warehouse in a box will stay there forever, and then when you're coming out, it'll be like brand new. Well, it isn't. So from a reliability perspective, if you have a stable system and something's working well, you should put all your energy, time and effort into making sure it stays like that. And you do that by keeping your foil clean and dry.
And preventing the need for having a spare in the first place.
Exactly. Rarely do companies, like suppliers of equipment, rarely do they want that equipment to last. Like hydraulics companies rarely put an offline filtration unit on them. At an oil sands plant I worked at, there was only one piece of equipment in that entire plant had an offline filtration unit on an hydraulic system. And it was the dredger that came from Holland. They had a dredger that'd come in and dredge the mud, the lake or whatever.
Tailings pond.
So they did it as a matter of, that's the standard, but anywhere throughout the plant didn't have an offline filtration unit. Hydraulic, reducer, lube system. I tell a lie, the TG did, but it wasn't really adequate enough. It was just 10 micron filter units.
But check in a box.
And wasn't varnish removal, that's for sure.
Yeah, it is the offline filter is still viewed as an add-on, as an accessory, and what we try and convey is that the inline filter, so the system, the filtering components that come with the piece of equipment are essential as well, but it's a complementary system to the offline. You have the inline filter, which is making sure that no chunks are getting sprayed out through your system.
It's the term I like to use. It stops trucks and buses.
Trucks and buses.
That's about it.
But as I'm sure you've experienced, trying to filter down to ultrafine levels using a high flow filter
Can't be done.
It either can't be done, or you're going to be just changing them constantly in order to keep up with the flow and not cause a restriction to the rest of the system.
Yeah, but it's strange that OEM suppliers don't do this as a matter of course. It's always an add-on, and they won't recommend it because you end up buying less parts. That's me being cynical, I guess. But yeah, it's a problem.
Yeah, we have seen a bit of a shift in that regard. There seems to be more attention being played to the oil as a vital part of machine reliability and thus reputation of that equipment in the marketplace. So CC Jensen does work with a number of OEMs at the supply level where the offline filter system is included with the piece of equipment. Some others, it's a recommended option.
Yeah.
So they can still, remain competitive, but offer their customers something that's going to extend the life and the reliability of the equipment.
Yeah.
So how do you approach having conversations with teams who are either skeptical of a proactive maintenance approach, treating the lubricants like an asset, and they tend to be stuck in a run to failure mindset?
Yeah, that's a good question. It's always difficult to change somebody's mindset or a culture of a place where they're actually used to doing it. And there are companies, and I won't name them, but like maintenance departments, I think that's quite fun, dealing with emergencies and firefighting. Because usually
Job security.
well, it's usually the firefighter gets the pat on the back because he's prevented the fire or put the fire out. But
I remember one customer actually where we sold a number of filter units to, and following them up at another point in time, discovered they'd all been turned off. And when we finally got to the bottom of why, it was because the maintenance guys were worried about losing work.
Yeah, I've seen that. Yeah, it's kind of where's all my overtime gone?
So how do you convey the concept that preventing or taking preventative measures early on in an asset's life is going to lead to less panic, less frenzied reactions to these catastrophic problems that are coming up?
Less stressful environment.
Less stressful environment.
A term I like to use, or a quote I like to use often, is without data, it's just an opinion. And you can Google that one if you want. But it's you need data, and the data comes from your oil analysis program. And the other thing I like to use is case studies, because you use them two together, and it's a tool. I like to say an educational tool, because you can sit with your maintenance group or your management group and explain the consequences of what those KPIs from oil analysis data or the case studies, whether it's something that's failed catastrophically, which could have been prevented. And I have lots of examples of them, unfortunately, but also case studies for what would have prevented a failure. So there's two aspects of that. Is I prevented this failure through doing this, and this. I've now got a filter unit on it. I'm doing consistent oil analysis to confirm that the oil's clean, the viscosity is correct, the additives are okay, and life's good. So it's not an easy thing to go into a place and say, you're doing everything wrong, because when you start somewhere new and you say that, you've alienated people. Yeah, I felt like saying it, and probably hinted at it, but you need that data to support what you're trying to achieve. And the other thing is, once you start doing this improvements to programs, filters aren't cheap. And when you're looking at a larger expense, whether it's one filter costing you $20,000 or 200 filters costing you $600,000, that's a huge investment. So your operations or your maintenance department who's signing off on that expense needs to see a payback, right? And it's got to be a proven payback, not a number you pull out of the air and say, I've saved you $5 million. It's got to be proven. And it's how you do that is through education, really. It's like you go through the data you've got, you show them the empirical evidence that somebody else has done, and that's how you do it. So it's not an easy thing to change your culture. But first thing you need is the data, the evidence to support that.
You mentioned case studies, something we run into from time to time. We do like to collect and build case studies, share it with people, but we often hear they'll pick on any little difference between two systems. So say you have the same oil type, they'll say, yeah, well, that's in a press, and we have valves and motors. So it's not the same, or it'll be two identical systems. And they say, "Oh, that's oil type A. We're using oil type B." So how do you translate those case studies that may not be exactly the same as what you're dealing with, but the principles is the point that you're trying to get across?
I think the key thing is you said there is the principles. It doesn't matter whether it's A or B. It's like a spool valve in one hydraulic system operating a different function than a spool valve in another system operating at a different function. That spool valve really doesn't know what it's doing. It's just doing what it's doing, what it's designed to do. So does one spool valve deserve cleaner oil than another one? Because if the one's got dirty oil, it's going to fill quicker than the other one.
We're sort of personifying the equipment sometimes and saying, oh, it's a little bit different for me than for that guy.
I don't tend to get hung up on criticality. My philosophy is it's an asset and it deserves to be protected or maintained to the best of your ability. And if it's worth doing and if there's a cost saving associated to it, then do it. It doesn't matter if it's a supercritical piece of equipment or not. I'll give an example. As the last place I worked at, there's a series of reducers on a Unox plant, 16 reducers. Each reducer cost about $80,000-$90,000. The impact on production, if it failed, was inconsequential because we had redundancy. But my argument was, well, this reducer still needs some TLC. It needs to be filtered. It needs a quality breather on it to stop moisture going into it, and it needs to be monitored. And if you want a reducer to last 7 or 8 years, which is what was happening, if you could double or triple the life of that reducer, all that work you've put in periodically filtering, sampling, putting a breather on it, pays for itself in a matter of months, literally, when you do the math. So you're going, zero criticality, but payback. And if you expand that philosophy throughout the plant, the cost savings, the less maintenance you do, the less spares you need, snowballs. And it can be quite significant over a short period of time, the amount of money you start to save.
So someone's listening today who is in maintenance or operations, and I'm thinking like senior management kind of people. What should they look for in their systems that might signal a deeper lubrication issue?
That's a great question. I say that because generally speaking, senior maintenance managers, operations generally don't get involved with the lubrication issues. They just
maybe that's the wrong question. Maybe it should be a culture issue.
Well, they generally don't get involved with it because they make assumptions that the maintenance department is doing everything in a world-class or best-in-class practices. And then in reality, it may not be like that. I'm not saying for every industry, but for a lot of industries. So the first thing I would say to them is I talk a lot about KPIs and how important they are, and generally what senior people tend to focus on is PM compliance, PM completion, and they look at, if not PM compliance is 100% correct, everything should be good. And generally speaking, that's not the case. You may have an ineffective PM program with 100% compliance, which doesn't really achieve anything. So what I'd say to those people in senior positions is talk to your people who look after your oil analysis program, assuming you have one, and say, show me the data that demonstrates that this program is robust and effective and it's saving us money. So I'm capturing the data, I'm reacting to it, I'm showing improvements over a period of time. Because what I see is a lot of companies I deal with, the data or the abnormal results haven't changed over a 5 to 6 year period. So they're generally not making any improvements and they're not getting any payback for their investment. And some companies invest thousands of dollars, hundreds of thousands of dollars in a program that doesn't really pay back any money. Is that effective? And your person running that program should be able to demonstrate that.
Do you think several different layers of people could be looking at that data and compiling it? And I'm thinking because there's often a deflection of the responsibility. The lube tech who's out there handling the equipment is thinking, oh, well, my boss should be taking better care of this. Maybe his boss is thinking, oh, the lube tech should be taking better care of this. So it's easy to deflect the responsibility and try and pin that on someone else.
Well, you're talking about lube tech, supervisor, superintendent. They all have a role to play. As a supervisor, you're basically giving the tools to the lube techs to do the job and to make improvements, and there's an educational aspect in that as well. You're kind of educating that we're doing this for a reason. It isn't just because I think it's a good idea, right? Or I haven't dreamed this up. This is why we're doing it, and this is the benefits you're going to see. So those KPIs, those concepts needs to be communicated at that level. And it's the same with your manager level, because he generally has to approve any expenditure. So it's a two-way street for education.
Is it
people who report to and people you report to and people who report to you when you're managing that program, understanding why you're doing what you're doing.
And is it going to be different conclusions that you pull out of the same data that will trigger interest with those certain levels?
That's a good question, because the answer is no. It's the same conclusions no matter what. You're sending the same message, whether it's up the hierarchical chain or down. It's like you don't kind of tailor it to one level of the organization. It's the same message. It's the same data. It's the same principles. So, yeah, it's but generally speaking, in my experience, your senior managers, and I've talked to CEOs and people at that level about some of these issues with lubrication, and they really don't understand it. And do they really need to understand it at a technical level? No, but they need to appreciate it and need to understand the consequences and why you're asking for all the funds to fix it. They will eventually see the payback, and they do, and they may or may not give you a pat on the back and say, job well done. But at the end of the day, you're the catalyst for making those changes. And I'll repeat it again, without data, it's just an opinion. You need the data.
So taking the leadership can happen at any of those levels. And what you're doing is conveying to the other people that you're working with the importance that you're placing on the program and the data that you're collecting and the implications of acting on that.
Yeah.
Would you say there are some more simple wins or some low-hanging fruit when it comes to improving oil reliability in a plant?
Well, yes, I'll say again, it's when you're talking with a culture of firefighting or run to failure, it's difficult to change. But then again, it's when you're talking about 4,000 or 5,000 assets, you're not going to change everything overnight. It's like the expression is, how do you eat an elephant? One bite at a time. So what I did at the last place I worked was one filter unit, use a filter unit, gather the data, present the evidence. This is doing a great job. We got one filter unit. Okay, great. Now I need many filter units to basically expand the philosophy that clean, dry oil extends the life of the equipment. So I'll say I keep talking about clean, dry oil because that's 90-95% of your problems in a plant, especially high moisture, high dirt, and contamination. So if you can fix 90-95% of your problems, your issues, the return on investment for that is huge. That's less failures you've got to deal with, less maintenance cost, less spare parts you need. And another thing I haven't mentioned, brought up yet, it's less energy your plant uses, because as a piece of equipment begins to fail, it generally gets hotter, it's creating more friction, it's taking more energy. So that's not an insignificant amount of cost when you look at something that's taken 500 or 600 kilowatts of power, right? When you multiply that by the amount of equipment you've got in your plant, it can be savings of anywhere from 1 to 5% of your total energy cost.
Wow.
That's a huge cost, right? Just for having clean oil. So
Reduced wear, friction.
Yeah,
heat.
so it's the whole, it compounds itself. Then your lubricants last longer, you're not doing as many oil changes. It's a snowball effect. And once people start to see that, they understand it and they buy into it. But like you say, when you talk to a run to failure mentality and change it to you're now proactive, and it takes years to do that because you can't wait for all that damage that's already been done to kind of filter through. So you say you're not going to fix it overnight. It's going to take time, and I say anywhere from 2 to 3 years before you start seeing significant changes. So an example I had at the last place I was working at, the maintenance supervisor came to me. He said, "We don't change as many reducers on a shutdown as we used to do." I said, "Why do you think that is then?" He says, I don't really know. I said, "Well, maybe you should talk to the oiler, the lube tech, and he'll explain it to you." "Oh, okay then." So, and it was basically down to you're not running the equipment with wet and dirty sludge. You now got clean, dry oil. It lasts longer. He said every shutdown we'd change 2 reducers. I said, "You don't do that anymore, do you?" "No." But it's educated people start to notice these things, take notice, and ask questions.
Right. Now, at several of the places that you've worked, you've ended up bringing in quite a number of CC Jensen units, and you mentioned the approach of putting one in place, gathering the data, presenting it, and then taking that to say, okay, now I could use another one over here. So
Yeah.
So I imagine with the volume that we've seen, you're not taking every individual asset with that approach. So is there a way of scaling that from one and then to many, to say, okay, this is how I've approached this one asset. So now I have 10 of these things, and you're going to see the same results there. That's a much bigger commitment for somebody to take. How do you convey the return on investment that's going to see that change?
Again, I kind of mentioned the KBIs from the oil analysis data, and typically I see return on investment of anywhere from 20 to 30. I invest $1,000, I'm expecting $20,000 or $30,000 back in that investment. And it's the maintenance people who work in the plant, they'll notice it. Less failures, less work, less spare parts. They probably won't notice you're using less energy, but that all takes time. But and I think the question you might be asking is, how do I justify having one filter as opposed to having 50 or 100 filters? Well, that's all. To buy 100 filters, that's a huge investment. You probably don't stock 100 filters.
I might be surprised.
I don't. But if you're starting from scratch, you don't have any filters, well, get one, prove it's worth, get another. So the way I did it at the last place, we buy one, we use it. Okay, I want one. Okay, I'll get you another one. But it's the thing to consider is you might have an asset that holds 50, 80 litres of oil. It still deserves some TLC, so I'll filter it. But then you have to upgrade the equipment so you can actually do that. You might have, in the case of that oil sands issue I was talking about, that had 1,000 litres on it. I'm going to buy a filter unit that's going to stay on it. I'm not going to periodically move it to another smaller filter unit. Plus, it's a critical piece of equipment, and it's an asset that's worth over $1 million. So the filter unit soon pays for itself, but you get to a level where you have enough filter units. So if you have an abnormal oil sample result, you have a filter unit there so you can use it. You just plug it in, run it for a day or two, take the sample, life's good. And eventually, over a period of time, if it's a reducer, it will clean itself up. Because there'll always be some residual contamination in the reducer if it's built up over over time. You won't take it all out in one filtration, put it that way. It'll happen over a period of time. Eventually, you'll take the sample result and it'll go, yeah, it's clean, move on. But in some places, and I've seen this, you're going, I'm consistently filtering this unit, and it doesn't matter how often, whether it's every month or 3 months, I put a filter unit on it, it's still coming back dirty. Well, I'll put a filter unit on it and I'll leave it, right? Especially if you got a reducer there, and some of these were like $250,000 reducers. I'll just leave the filter unit on and make sure I get the maximum amount of life out of it that I can. But the reason it's like that is because it's been neglected for 5-10 years in a dirty environment. That dirt is built up, right? So you're not going to take all that dirt out in 2 or 3 days of filtration. But then again, it's still having an effect on the moving parts, the bearings, the gears, and the condition of the oil. So buy a filter, put it on, and just forget about it.
It's really more about building the culture of responsibility and of caring for the assets than it is about building the fleet of filters.
Yeah, I'm looking at data. I'm going, do I have enough filters to cover this area? Because the filters are transportable, probably weigh about, correct me if I'm wrong, 25 pounds.
Somewhere around there, a little more when it's full of oil.
You can easily transport them and put them from one asset to another, but you don't want to be taking it from one end of the plant to the other, or up 3 flights of stairs and all this. So generally, if you have enough filters, you leave it in that area and it'll cover X amount of assets. And if it's, like I said, if it's one way you're continually getting contamination, high ISO, or some, like the seals maybe compromised, you might get water ingress, then you might look at leaving a filter unit on. But it's the data from your oil analysis program drives what you're doing. It's
absolutely.
If you don't know, then you're kind of where's it go next? Where's it go next? So you need that data.
Shooting in the dark.
And people assume that, again, I talk about people think a filter's expensive. I've had people say, well, oil analysis is expensive. It isn't. It pays for itself in a matter of months. You get that data, you react to that data, and you correct the anomaly.
And there's ways to spend money on both filtration and oil analysis that is cost you a whole pile of money and gets you no benefit. But there's also ways to spend certain amounts of money and get exceedingly great benefit.
People assume that oil's free. It doesn't cost you any money. Well, when you're changing a oil in a gearbox that's got 100 litres of oil, you're looking at the $500 expense there. That buys you quite a lot of oil samples. And it doesn't really achieve anything, just changing the oil, which I kind of alluded to earlier on. But it's an education. It's getting people kind of aware that things need to change if you want to make those improvements. Get away from that firefighting mode, the run to failure, and be not predictive. I say proactive. You need to be proactive in kind of preventing these failures happening in the first place.
Well, that's fantastic. I've learned a lot. We've learned a lot from you over the years, and we appreciate the approach that you've taken to treating each individual asset with the respect it deserves. And I know that has behind you is a wake of improvement at the various plants that you've been at, and we know that those are continuing to this day. The culture that it has created. Once a robust culture is built, that can sustain itself because the mindset is always looking after the equipment and treating the oil and the assets with the respect that they deserve.
I will finish on this. Start treating your asset as if you own it and you're not renting it. And I think you'll see your attitude towards that will change.
So if you're footing the bill for the maintenance or the replacement.
If you owned it, you would look after it a lot better than what I see at the moment.
Well, that's coming from a guy who's really taken ownership of his equipment. So great to have you with us today, Brian. And we'll do this again, I'm sure.
Yeah. Thank you, Paul.